Hey, what's going on, everyone? I want to take the time out to kind of compare the Z1 ported manifold compared to a stock, just to see the dimensions of how much porting that they're doing and how much of a difference it is compared to stock. Then I want to compare the differences between the VHR upper manifold design to the HR upper manifold design. Reason for this is because Motordyne sells upper manifold, which is just a modified HR manifold to adapt onto the VHR, lower manifold, be just pretty much a bolt-on affair. And then also within the HR community, it's also popular to swap on the VHR setup, being that it's the upper with the lower and the fuel rail. So I'll get into that in a little bit. The first thing I want to do again is to just compare the ported Z1 manifold to stock. What is different and is it significant? So in my previous video, a long time ago, I compared two ported manifolds that I've had, one being the Rabbit Hole Motorsports ported by Reg, and then another one that was ported by CFM Performance. So let's get into it. So first thing you kind of notice is the texture. Of course, this is how normally a ported manifold would look like when it's ported. And then these are the individual outlets. It looks all very consistent, right? So let's look at what a stock one would look like. So this is stock untouched. You can see how smooth it is. I mean, this is just oil residue. And the individual ports. And let's compare it side by side. If I can hold it. All right. So let's get into the port dimensions. For this, I'm going to focus on the pretty much just the area of the openings. For the measurements, I tried to take 3 measurements and then average that out to minimize human error. And then I took the average of all 6 ports to get the value of, just the opening area. So for the Z1, I got 2010.5 millimeters squared, right? So this is just the opening area of this. The stock manifold, I got 1,972. If we're looking at percent difference, that is 1.9 over the stock manifold. So, I mean, you could say that's marginally better because if we're looking at the VHR, I also took measurements off of this. The average of the VHR ended up being around 1,990. So compared to the VHR, it was a little bit more. So that's like under 1%. So it's like right at 0.9%. I mean, could some of it have been human error with me just measuring it? Possibly. So, I mean, at 1.9% of the Z1 over stock, I mean, that's, kind of hard to justify sometimes. I mean, when, the price of this is, I think $500 if you don't provide your own, but it's like maybe 2 something. Don't quote me on that. If you provide your own, that's just like the port work. Because I know a lot of companies, they port more, but port size isn't the only thing that is important, because you have to worry about how you're porting it, where you're porting it. So that's something to also consider. And because I don't have a flow bench, I don't know the flow rates of each manifold to say that, oh, just because the area is only 1.9%, that this is insufficient or insignificant. So I'm not saying that. I'm just merely pointing out that if we're looking at port area, and of course I'm averaging everything, Z1's porting is 1.9 over stock. Then if we're comparing the throttle body inlet, pretty much, was it Z1 I got 63.1, stock I got 63.25, the HR got 63.13. So that 10th difference, that's definitely measurement error. So I mean, that's very insignificant. So we can pretty much say that across the board is 63 millimeters. So that's all the same, right? And then if we're looking at any other differences for the Z1, of course, they provide this logo, which is kind of cool. You can kind of see it, when you pop the hood, it's like, oh, hey, that's a Z1 upper manifold. But outside of that, everything else is the same. Now, moving on to the design differences between the VHR and the HR upper manifold. Just from appearances, you can already tell that, of course, the VHR has the 2 vacuum ports at the bottom, which connect to the PCV valve. This doesn't have the vacuum ports here, and I forget how. Oh, I see. Because there's one port in the back here where it is utilized for the PCV valve, right? So that's some of the outer appearances. Then the major one that provides the performance differences and characteristics would be runner length and these reservoir chambers. So when we're looking at the VHR, we see that the runner length is very short. This distance, I measured from here, was roughly 25 millimeters. Compared to the HR, this distance was 50 millimeters. So we can almost just say like the runner length of the HR is double what it is on the VHR. So characteristics of longer runner length means more mid-range power. Characteristics of a shorter runner length means more peak power, right? So different areas of power. So I think the idea of using this manifold, for the G37s or 370Z is that it moves the power band or usable power towards the center. So like daily driving, it's good. Maybe like really tight technical courses, autocross, I could see this being really good also. So Motordyne sells a manifold that is just this, of course, with the hose slotted to be able to fit on a G37 or 370Z. And then another characteristic between these two that's different is, as I mentioned, these chambers. They're pretty much where the air kind of sits before it gets distributed into each cylinder. Just from visual comparison, you can see that the VHR is significantly bigger than the HR. And then if we're talking about area, and I'm only talking about area because height-wise, they're about the same. So, I mean, I could multiply, the thickness of here to get the volume, but I think just comparing the area would kind of give you the reference idea, especially if we're talking about like percent differences. The VHR came out to be 25,600 millimeters squared, and then this is just one chamber. The HR came out to be 21,350. So percent difference wise, that's 16.6%, right? That's just in this chamber. Yeah, so that's mainly the big thing. And again, just going back, longer runners, mid-range torque, shorter runners, more peak power. So trying to see how I'm going to explain this. A lot of HR guys, HR like 350Z with HR engines, will utilize installing a VHR manifold because of these links. And to make it work, all you really have to do is get the upper, the lower fuel rail, and of course the injectors. The OEM ones can plug into here. You can use the 370Z or the VHR injectors. It's a little bit higher flow than the HRs, not too much, but just a little bit. So you can use that, but you do need the fuel rail to make this setup work on an HR engine. And it's a direct bolt-on, you don't have to like cut anything. So very simple. Now for the VHR engine, to make a HR work, you can kind of see, I'll just show you how it kind of looks and why you have to like slot the hose. So of course it bolts on, and you can kind of see this hole lines up and this hole lines up. Then if you kind of look down, these 4 holes are actually too low. So what you got to do is you have to slot it. You have to pretty much make the slot about that wide to make it work. And to do that, you have to remove these metal cylinders, which is used to help bolt the upper manifold to the block. If you look at the Motordyne M37 or M370, it comes with this mounting plate, and that allows you to bolt the manifold to the lower manifold, the upper manifold to the lower manifold. So that's something to kind of keep in mind. Another option that no one has really done is to try to utilize the HR lower also. So the only problem with that is on an VHR, the valve cover has some humps because of the VVEL. And then also the VHR also has 2 fuel dampers on the rail too. As you can kind of see, it kind of works on the HR, but the ears for the bolted down is different. So you might have to rig something up to like make the tabs work, but most of the time to make a HR upper manifold fit, it's just modifying it and then just reusing the lower of the VHR. All right. I guess since we were talking about the lower manifold, is there any difference between the VHR lower manifold versus the HR lower manifold? And of course, I also went ahead and took some measurements. For the inlet, the port areas actually ended up being pretty close, if not pretty much the same. I mean, the percent difference was under 1%. It's like 0.18. Same thing with the outlet ports. The percent difference ended up being 0.18. So definitely no difference between the lower besides just the physical differences of how it mounts because of the differences of the engine. So the main differences just come from the runner lengths and the chamber sizing between these two. And based off of your application, you want to kind of see which one works best for you. And then, of course, going back to the Z1, if we're talking about port sizing, it's roughly 1.9% ported more than the stock. So I kind of hope that helps you kind of decide if you want to buy a Z1 manifold or go through another vendor or try porting it yourself. And then, of course, this video helps you decide if the M370 manifold is worth getting and how different it is from a stock VHR manifold. So this graph is Z1's graph comparing to the Motordyne M370. And you can see that there's a gain of 7 to 8 horsepower and a loss of about 2 to 3 torque. This is Z1's own graph, so take it for, what you will. So I hope this helps. All right, thanks guys.